So question 3, here's a diagram of a function, so sin x minus x to the power of 3 over 2, where point A with coordinate q is a stationary point in the curve, so obviously the gradient is 0 at that point there, so it's the local maximum, I guess. And the equation f of x equals 0 has a root alpha in the interval 0.8 to 0.9, so somewhere it crosses between 0.8 and 0.9, so between 0.8 there and 0.9 is there, something like that. Explain why x0 equals q. It's not suitable to use the first approximation. Well, if x0 equals q, that's the stationary point, so the gradient is 0, therefore we can't evaluate, so let's just state that. We can't evaluate the requirement for Newton-Raphson, which is f of x over f dash of x. So gradient is 0 at x0 equals q, implies f of q over f dash of q cannot be found or does not exist. Implies cannot apply, cannot apply. Newton-Raphson. Okay, part B. Taking x naught equals 0.8, first approximation to alpha, apply the Newton-Raphson process once to find f of x to process once to f of x to obtain the second approximation to alpha. Give your answer to 3 decimal places. Okay, so first of all we've got to find f dash of x, so let's just write this out. So f of x is sin x minus x to the 3 over 2. So f dash of x equals cos x minus 3 over 2 x to the half. So let's work out the f of 0.8 equals. So we've got to do the sine. We know we're in radians, so we're good. Sine of 0.8 minus 0.8 to the power of fraction button 3 over 2, which is our function, equals, oh gosh, 1.81 times 10 to the minus 3. So let's keep a good level of accuracy. So 1.81433 times 10 to the minus 3. And then the f dash of 0.8 equals, right, so now we'll do the cos 0.8, close brackets, minus fraction button, whoops, let's put it so you can see it, 3 over 2 x to the power of, or 0.8 I should say, 0.8 to the power of a half. I'll use a fraction button, 1 over 2, why not make it look pretty so you can see it. Well, you can't see it, it's a big light splodge on it, so let's press that, press equals, and we get minus 0.64493, so minus 0.64493, and maybe a little bit more accuracy, so 93407. Okay, so now we'll do our next estimate. So x1 equals x0, which is 0.8, minus the f of 0.8, which is 1.81433 times 10 to the minus 3, over f dash of 0.8, which is minus 0.64493,407, keeping lots of accuracy as we go through this. Put those into our calculator and we'll get something like 0.802813. We're asking it 3 decimal places, so 0.8028 makes the 0.8028 makes it 2 vector 3, so 0.803 to 3 decimal places.